Okay, so we got our second part of our review for Q-2-1. This time it's dealing with heat and specific heat. So we just kind of want to look through here and fill in this chart the best we can. We want to pick out the important information, like we have 100 grams of water. You know, water has a specific heat of 1 calorie per gram degree Celsius. And the water starts off at 22.4. Then we have metal, which has a mass of 75.25, trying to find its specific heat. And it starts off with a temperature of 99.3. After a while, they reach the same temperature, thermal equilibrium, 32.9. So the temperature of the water went up, but not a lot, and the temperature of the metal went down quite a bit. So we can find delta T by doing some subtractions here. 99.3 minus 32.9, and then 32.9 minus 22.4, and that gives us our changes. So this one went down 66.4. Don't worry about signs. This one went up 10.5. We can use this to find our Q. So we take the mass times change in temperature, specific heat is 1, and we get 1050 for Q. So once we know that Q is 1050, we can then divide by the mass and the change in temperature, and we come up with our specific heat, which is going to be 0.21, which is pretty close to what it should be, in fact. Turn the camera here, take a look at my computer screen. One easy way to check it is just type in, specific of aluminum in calories per gram C. And you can see right away it's matching 0.21. Maybe not the best choice Yahoo Answers, but since it matches, here's another one, 0.22. And you could scroll through here and you could find more things that would kind of confirm. Here's another one, 0.22. So, I'm pretty sure that that's right. The second part of this problem deals with kind of the issue of being able to turn one form of energy into another. If we look specifically at Q, which is 1050 calories, we can use this amount of heat and realize that Q could be turned into another form of energy, kinetic energy. Well, usually the energies for Q would be calories, but the energy over here would be a potential energy is what I meant to say. And this is usually measured in joules. So what we're going to do is we're going to say 1050 calories over 1. Turn calories into joules. 1 calorie is 4.18 joules. Just multiply across, and we get 4,389 joules. Well, this number of joules is the same thing as saying potential energy. So potential energy is equal to mgh. It said it was a 10 kilogram rock, so I'll put that in for mass. We're on Earth, so gravitational constant 9.8, and we can solve for h. So all we got to do is really divide our answer by 98, 9.8 times 10, and we figure out how high we can raise it. Looks like we can raise it 44.8 meters with that much energy that was transferred between the metal and the water. So that's how you do this. That's how you relate these things. All right. Not too bad. Under 5 minutes.